ideal gas equation. As I've explained it to you, the ideal gases are those gases which follows Boyle's law, Charles' law and Avogadro's law strictly, and we know that volume is inversely proportional to what? Pressure. Volume is directly proportional to temperature. Volume is directly proportional to number of moles at constant temperature pressure. What we can conclude is volume is proportional to NT by P. So we can write PV is proportional to NT, or PV is equal to nRT. So this equation is called ideal gas equation, where this R is called universal gas constant, and whose value can be determined from PV over what? NT. If we keep the pressure 10 to the power 5 pascals, volume 22.4 liters into 10 to the power minus 3, we will change it what into liters into cubic meters, and then one number of moles, temperature 273 Kelvin. What we get, we can put even this one 10 to the power 5 pascal as 101.325 pascal also. So that, because we know 1 atm is this much, so what we get is we get an answer of 8.314 joules per Kelvin per mole. So that's the value of R we have actually. Now, if we want this R to be in terms of liter atmosphere, we can write this comes out to be 0.0821 liter atmosphere per Kelvin per mole. This comes when we put this pressure as 1 atm, temperature volume as 22.4 liters, one number of moles 1, and this 273. This is the value which we get now in this case. And if we take the pressure in bar, it will become 0.083. So it becomes 0.083. It will be liter bar per Kelvin per mole. And if we want the R in terms of calories, we know it is 4.184. So if we divide, it comes out nearly to be 2 calories per Kelvin per mole. So these are the values of R, the gas constant, which we must remember. Another important thing about this gas law is, from this formula we can find out, is that it is actually the amount of the work done to raise the temperature of 1 mole of a gas by 1 Kelvin, and that's the amount of the work done or to be done, or that's the amount of energy required to raise its temperature by 1 Kelvin, for 1 mole of a gas by 1 Kelvin. So that's the significance of the R is.